So I read someone's post the other day. Why don't they teach us anything useful in school? When will I ever need to solve for x IRL? I'll tell you when, silly pants. Let's say your favorite influencer makes $2 for every 1,000 views, and you found out that they made a total of $10,000 off of one video. How many views did they get on that video? Go ahead and try to figure it out. I'll wait. So here, your unknown is the number of videos. Let's call it, I don't know, X. And you know their rate, along with how much they made at the end. So you can set up the algebra problem as the number of views divided by 1,000 times $2 is equal to $10,000. Classic algebra problem. Now, what happens when you add revenue from subs into the equation? Or Patreon donations? Now you have what's called a polynomial equation. And that, ladies and gentlemen, is what we'll be covering in this video. Don't forget to like and subscribe. JK. In this video, we'll be covering algebraic terms, degrees of a polynomial, adding and subtracting polynomials, the law of distribution and factorization, and lastly, multiplying and dividing polynomials. Okay, let's get started. Now, in order to understand what a polynomial is, we first need to know what a monomial is. It is just a bunch of unknown numbers called variables linked together through multiplication and written in shorthand form. So here we have x as a variable, n to let us know how many times the variable is multiplied by itself, and the coefficient a, which tells us how many of those are being summed together. The prefix poly translates to many in Latin, and the suffix nomial translates to term. So a polynomial literally translates to many terms, and in math, we chain these together through addition and subtraction. The next thing that you need to know is that a polynomial expression is also characterized by having multiple degrees. A degree is the power attached to the variable. It does not count as a degree when the power is attached to an integer. A degree of 2 means that there's a square attached to the variable. A degree of 1 means it is just the variable. And a degree of 0 means that there is no variable. Furthermore, the degree of a polynomial is the power of the greatest exponent and tells us up to how many times the graph of the polynomial will cross the x-axis. Key phrase there, up to. For these 5 examples, go ahead and pause the video and tell me the degrees of each polynomial. Okay, you should have gotten 12, 4, 23, 1, and 0. Next, let's talk about adding and subtracting polynomials and go into how to manipulate them. First off, another phrase for adding and subtracting polynomials is combining like terms. I'm sure you've heard of this before, but if you haven't, just know that for the rest of math, this needs to be second-hand nature. So definitely practice this until you can do it without even thinking about it. Here are the steps for adding polynomials. First, remove any parentheses. Second, group the same variables and indexes together. And lastly, combine the coefficients in each group. For example, here we have 3y squared plus 5y minus 6 plus 7y squared minus 9. All right, for step 1, let's remove the parentheses. In step 2, let's group up the similar terms. We get 3y squared plus 7y squared plus 5y minus 6 minus 9. Finally, let's add the coefficients. We get 3 plus 7 is 10y squared plus 5y, that didn't change, and the negative 6 minus 9 is negative 15 as the constant. Moving on over to subtracting polynomials, we just need to tack on one extra step right before step 1, which is distribute the negative. So, step 1, distribute the negative. Step 2, remove the parentheses. Step 3, group similar terms. And step 4, combine the coefficients. For example, we have 3x squared minus 2x plus 5 minus negative 6x squared plus 7x plus 4. In this example, step 1 is to first distribute the negative, meaning since we are subtracting everything on the right, we need to flip the signs for all the terms on the right. Another way to look at it is as though you are multiplying a negative 1 against all the terms on the right, hence distributing the negative. Once we do that, then we can treat it like adding polynomials. We'll remove the parentheses and group up the like terms to get 3x squared plus 6x squared minus 2x minus 7x plus 5 and minus 4. We add the coefficients and we get 9x squared minus 9x plus 1. Okay, pause the video and try these two. For the first one, there are no parentheses, so we are just combining the like terms. But notice how there are two different variables, x and y. So we would combine all the x's together and all the y's together. We get 3x minus 5x plus 4y minus 2y, which equals negative 2x plus 2y. Easy enough, right? Let's try the second one. We are subtracting two separate polynomials from each other. So we will need to distribute the negative first before we can combine freely. So the right polynomial becomes negative 2x cubed minus 8 plus 4x to the 5th power. Then remove the parentheses and group up the like terms, moving them so that the highest exponent is to the left. We get 4x to the 5th power minus 13x cubed minus 2x cubed minus 11x plus 7 minus 8. Combining the like terms, we get 4x to the 5th power minus 15x cubed minus 11x minus 1. Final answer. Great job! Don't forget to practice this more until you can do this without thinking about it. Okay, next, before we get into multiplying polynomials, let's dive deeper into the law of distribution and factorization. The distributive property states that multiplying a sum or difference by a number is the same as multiplying each number individually. For example, 2 times 3 plus 4 is equal to 2 times 3 plus 2 times 4. Using the order of operations, on the left we have 3 plus 4 as 7, then times 2 is equal to 14. On the right, we have 2 times 3 as 6 plus 2 times 4, which is 8. And 6 plus 8 is equal to 14. So it checks out. Now, let's apply this to polynomials. We have a times b plus c is equal to a times b plus a times c. So to get from the left to the right, we multiplied each term in the parentheses separated by an addition or subtraction sign by a. In other words, we distributed a to both the b and the c. We only do this when it is separated by multiple terms. We do not need to do this when terms are linked together through multiplication or division. Now, let's say we want to undo what we just did. We will need the factorization property. Similar to composite numbers, polynomials can be factored into polynomials of smaller degree. So, in this case, what is the common factor on the right? The a. So then we can factor that back out to the original. Let's take a look at an actual example. Here, the 4b needs to be distributed to all terms inside the parentheses. Then we combine like terms, just like how we would in adding and subtracting polynomials, and get 4b to the 4th power minus 8b cubed minus 16b squared plus 20b. To undo this distributed form, we notice that all the terms are multiples of 4b. Therefore, we can pluck a 4b out of all of them and move it out. When we do that, we get the original expression. Go ahead and pause the video and see if you can distribute this. Okay, so once you have multiplied the 3x to all the terms, you should have gotten 27x cubed minus 3x squared plus 9x. Alright, now let's see if you can factor this. In this one, we see that both coefficients are multiples of 6, so we can take that out. Also, we see that both have at least one v, so we can take that out too. So effectively, we factored out a 6v, leaving 2v plus 3 in the parentheses. Okay, now that we know how to distribute and factor, let's continue into multiplying polynomials. Here, we will need to use the law of distribution, but on a larger scale. Before, where we would have a term times an entire polynomial, here we will have at least two polynomials multiplied together. When you see this, you will need to multiply every term on the left with every term on the right. Let's try this with a couple of binomials. You may know this as foiling. The key here is to work methodically. Since every term on the left needs to be multiplied with every term on the right, we don't want to miss anything. Let's start with a, which will be multiplied by c, plus a multiplied by d. Then we move on to the b. We get b times c plus b times d. Let's put this into an actual problem. Here, we will multiply 2x by 3x and get 6x squared, plus 2x times negative 7, which is negative 14x, plus 1 times 3x, which is just 3x, plus 1 times negative 7, which is negative 7. We then get 6x squared minus 11x minus 7 as our answer. Your turn. Go ahead and pause the video and try these two. For the first one, we start by distributing everything on the left with everything on the right. We get 4x squared times 6x squared, which is 24x to the fourth power, plus 4x squared times negative 2x, which is negative 8x cubed, plus 3x times 6x squared, which is 18x cubed, plus 3x times negative 2x, which is negative 6x squared. We then combine like terms and we get 24x to the fourth power plus 10x cubed minus 6x squared. Getting it so far? For the next one, we have multiple variables, so keep that in mind. 10y to the fourth power times 4y cubed, which is 40y to the seventh power, plus 10y to the fourth power times negative 6z squared, which is negative 60y to the fourth power times z squared. Next, we have 2z squared times 4y cubed, which is 8y cubed times z squared, plus 2z squared times negative 6z squared, which is 12z to the fourth power. For this one, there are no like terms to combine, so this is the answer. Good job! Now that you have this down, let's move into dividing polynomials, otherwise known as rational expressions. Remember that in math, rational is synonymous with fractions, so these expressions will just look like fractions. And just like in multiplying polynomials, the distributive and factorization properties apply here. For example, let's say we have 10x squared plus 8x all over 4x. We need to divide both the 10x squared and the 8x by the 4x because they are separated by the addition sign. We then get 10x squared over 4x plus 8x over 4x. This simplifies to 5x over 2 plus 2. Do you see how we distributed that 4x to both the 10x squared and the 8x? This is as opposed to if the 10x squared and 8x were not linked with an addition sign, but with a multiplication sign. Then we would simplify the numerator first into 80x cubed over 4x, which simplifies to 20x squared. Definitely a different answer. Going back to the original expression, another way to solve this is to factor first. In the numerator and denominator, you can factor out a 2x, which will leave a 5x plus 4 in parentheses in the numerator and a plain old 2 in the denominator. The 2x's all cancel out and you're left with 5x plus 4 over 2, which simplifies to the same 5x over 2 plus 2. Alright, go ahead and try these examples. Okay, for the first one, we divide all terms in the numerator by the term in the denominator. So we get 2x over x plus 5x squared over x. This simplifies to 2 plus 5x. But just to keep it clean, let's rewrite it with the highest index on the left. So it becomes 5x plus 2 instead. For the next one, we divide all terms in the numerator by 3x squared. But let's actually pause and see if there's anything else we can do to make it easier. Notice anything about the terms? They are all multiples of 3x. So how about we factor out a 3x from all of them? Once we factor out a 3x in the numerator, we can cancel it out along with a 3x in the denominator. We are left with 9x squared plus 4 over x. Of course, we can just leave it like this, as it looks pretty clean. Or we can distribute the x in the denominator to both the 9x squared and the 4, which would turn the expression to 9x plus 4 over x. And finally, for the last one, we can solve this a number of ways. The easiest way is to recognize that the numerator can be factored to x plus 3 times x plus 3. See our video on factoring trinomials for a deeper explanation. So here, once we have that new numerator, we can just cancel it out with the x plus 3 in the denominator. And we are left with x plus 3 as the answer. But wait, why don't we need to distribute the denominator to both terms in the numerator? Good question. Because there's a multiplication sign between the two x plus 3's in the numerator. Had they have been separated by an addition or subtraction sign, we would have needed to distribute. Did you catch that? Perfect if you did. The moral of the story is, these methods are just like tools to help you solve the problems. Depending on the problem, you can use different tools. And sure, you can use a wrench as a makeshift hammer, but with enough practice, you'll be able to identify which tool is best in solving any given problem. Well, my Vanguard, I hope you learned something new about how to manipulate polynomials. Again, in today's lesson, we learned what polynomials are, how to add and subtract them, the law of distribution and factorization, and lastly, how to multiply and divide polynomials. Until next time, bye!